So the number one technique is to use a table of antiderivatives. Use a table of derivatives backwards. So you have f of x and its derivative 1 over x. And you know the antiderivative of 1 over x is ln x plus a constant. Who's to say what the antiderivative of ln x is? Anyone? Who's to say what the antiderivative of ln x is? So you must know how to read derivatives and how a table of derivatives and how to read it backwards as a table of antiderivatives. Not to confuse yourself. That is to say that the antiderivative of 1 over x is ln x plus c. And not to say that the antiderivative of ln x is 1 over x plus c. You don't know your calculus 1. Very good. So the big problem is finding antiderivatives. This is what we're going to concentrate on in the first half of this course, or certainly the first 2 or 3 weeks in this course, and how to apply it. You'll find out that there are many applications of antiderivatives. That is to say, applications of integration. That's to say, applications of the area problem. Sometimes you may calculate an integral and find a volume. Now, we are going to learn some tricks just for the sake of being able to integrate a few more things. The most important way to find antiderivatives is to use a table of derivatives. I did give you one last time? Yes. So that is the most important way to find antiderivatives. Next, we will learn a few tricks. In fact, in Calculus 1, you would have learned some tricks. Anyone know learned an integration trick from Calculus 1? U substitution. I'm going to go quickly over U substitution. If you did not have it, you want to go and review it and go to the tutoring center or come and see me. Because I taught it in my Calculus 1 class. U substitution. This is the continuation of review. When is the U substitution method appropriate? Well, now that depends. It really depends. The point being, the trick. What is the little tool in your repertoire or in your arsenal of tools? Meaning that you have a bag of tools. You got a screwdriver, you got a hammer, and you want to bang a nail. Don't bring out the screwdriver. Bang a nail, you don't bring out the screwdriver. Hey, I want to bang this nail and bring out the screwdriver. It's going to work. It's not going to work. The question is, when does the U substitution work?
When there's something you cancel out. Like, yeah. When you have something that you can divide out.
Yes, that's a good observation. Before we go into that, it's when you see something that you kind of know how to integrate. Something like this. Because it kind of looks like this. Oh, please don't review your calculus 1. What is the antiderivative of 1 over root x dx? Good. Go and review your calculus. Huh?
2x to the 1/2.
Very good. You say to yourself, use the power rule and a table of antiderivatives. Dr. J was kind enough to provide us with. So this is this. And then you'll use your power rule, but this is actually 3/2 over 3/2. Oh, I'm sorry, I mean the 1/2. Got no exponents, of course. So that's that one and divide by what you get. This is 2 root x plus c if you know some fractions. So this kind of looks like that beach. Not quite. So you say to yourself, well, why should it be hard to integrate this if you know how to integrate this? And the answer is, well, let's make a little u substitution to change this. That is the first aha you will have when you use the u substitution. Ah, this is fine. The little u substitution, it kind of simplifies. Another example is something like this. Or something like this. Yeah, those are begging, screaming, yelling for the u substitution. The appropriate u substitution would be here, u equals 2x plus 3. And here would be 3x, and here would be 2x minus 7, and we know how to integrate x. And we know how to integrate 1 over x, and we know how to integrate x to the power 2. So, of course, you want to keep your head straight, so you will use different variants. Very good. So, you will make a u substitution. So we'll do a substitution like this. So you will change your variable integration from x's to u's, but then that's just letters. That's just letters. Very good. Now, by the way, what is this? It's a function of x. The antiderivative function or the area function x to the power 20, the function that differentiates to x to the power 20. Most certainly, it is a function of x. What is this? It is a function of u. U to the power 21 over 21. What is this? That is a number. The area under the function x to the power 20 between 5 and 1 is a number. So that, being a number, I realize that this is immaterial. What is to say? Although, these two things are different. What you say, I want the area under the function that you, whatever you put in, you multiply by itself 20 times. That function, what's the area under that function between 1 and 5? Whether you want to call it x to the power 20 or u to the power 20. The number, in fact, it's this number here, 5 to the power 21 over 21 minus 1 to the power 21 over 21. Excellent. What is this?
Trash.
It's total trash. We will. Oh, people will write this on test. Okay? I assure you, I would be happy to make a wager. Done 10,000 dollars now. That nobody's going to write such a thing. Take a wager with me, please. It's in your class. Okay, total trash. My favorite Sonic Youth song. You want a Sonic Youth? Before your day. Before Nirvana, with the real branch music. Funky. So, you do not integrate x's with u's or u's with x's. That is to say, when you make a u substitution, it will work, provided things cancel. If things are not canceling, and you're left with x's and u's and x's, you want to bring out not the screwdriver but the hammer. That is the extent of the guidelines I can give you whether the u substitution works or not. It will work provided things cancel. In other words, you change your integration from x's to u's completely. And if you find yourself still with x's after you make your u substitution, you knew that was the wrong truth. Okay, it would be the wrong truth. So, speaking to that, it will become for you an exercise to determine what is the correct substitution, even were a u substitution to work. For example, if you have something like this. Don't tell me off tangent or near tangent. It's not. But what is the correct substitution to make in this situation? The answer is the correct substitution that will work here is u equals x squared plus 20, not u equals x. Why? Because I have a lot of gray hair, and I know that one works, and the other one doesn't. So the more you practice, the better and more familiar you will